Welcome back. Topic 4, notes. This is part 2. We are shifting gears from where we were at on the previous side of this page with solving by square roots. Now we're looking at solving systems of equations, and specifically looking at substitution and elimination methods for solving. So our first part here is going to be substitution. Again, I went ahead and copied and pasted something so that I didn't have to write all this out. So from previous years, if you know the value of one variable in a system, you can find the value of the other variable by substituting the known value into one of the equations. And it doesn't just have to be a value, it can be an expression, such as what we're doing in examples 9 and 10. So as I get started here, I want to remind you that if I go too fast, you are able to pause and rewind as much as you need, so please do so if you need to. Alright, so we know what y equals in our first equation. It's 5x minus 2. We're going to substitute that into our second equation, which will give us, my color didn't change for me, which will give us 5x minus 2 equals 4x plus 11. And then we're just solving an equation like we learned in our previous topics of algebra review. So we get our x's on the same side, subtract 4x from both sides. We have 5x minus 4x is 1x, or simply x, and then our minus 2 equals 11. One last step, we add our 2, so x equals 13. So that is not our answer, that's just part of our solution. That's the x coordinate of the point of intersection, essentially. So we have 13 and then something for the y. So let's figure out our y. So we're just going to use either of those two equations. I'm going to use the top one there. Say y equals 5x minus 2. And we're going to plug in what we just learned that x is. And I was writing too fast and forgot to stop and do that. So I like to use parentheses for that. So instead of writing the x, we're going to substitute what the value that we just solved for x is, which is 13. So we're going to plug in that 13 into our equation. So I have y equals 5 times 13, 65, minus 2. Finishing that out, simplifying, we have 65 minus 2 is 63. So our solution is the ordered pair, 13, 63. So as I mentioned on the previous half of this, please check your work. You can plug that in. You just need to make sure that it works in both equations, not just one. If it's one, you made a mistake if it doesn't work in both of them. So double check, make sure it is the correct solution for both of those equations. So if you think of graphing, which we're not reviewing solving by graphing, but if you think about graphing two lines, again, what we just found was the point of intersection. So where do those two lines cross? That's why we have our x and our y value there. And number 10, we have y equals negative 3x minus 19, and y equals 7x plus 1. So again, we're going to substitute. We know that this value for y can be plugged into that one because they both say y equals. So we write our equation, negative 3x minus 19 equals 7x plus 1. And then again, we're just solving an equation. So we get our x's on the same side. If you prefer to put them both on the left side, that works. I just prefer to have a positive value for my x, so I need the smaller one to do that. And then we have negative 19 equals 7x plus 3x, and x, and then our plus 1. So to get x by itself, we finish solving this. We have 2 steps left. Subtract 1. Negative 20 equals 10x, and then we divide by 10 on both sides. So x equals negative 2. Again, that's just my x-coordinate. We still need a y. So we take one of the two equations. So I'll take the first again. And we substitute. So we have y equals negative 3 times whatever x is, minus 19. And what did we just find out that x equals? It was negative 2. So then we finish solving, or simplifying. We have y equals, negative times negative is a positive, 3 times 2 is 6, minus 19, y equals negative 13. So that is our solution for number 10. Again, you can plug that in, check, make sure it works in both of our equations, and confirm that yes, it does. Alright, from there, I want you to take a moment and pause and try the next two. Try numbers 11 and 12 on your own, and then we'll look through them and see how you do. Okay, hopefully you paused and tried 11 and 12 on your own. So let's look at number 11. Finish with my technical difficulties there. So we have numbers 11 and 12 here. In number 11, and I have that highlighted down there, we end up with some fractions, so it still starts out the same. We plug in what we know y equals in 1 into the other equation. We solve for x, but down here where it's highlighted, we have negative 4/6. That reduces to negative 2/3. You're still going to plug that into one of the equations, doesn't matter which one, and we're going to get a fraction for both in this case. It's not any different in the work, it's just a little bit more intimidating for some of you that are a little bit more scared by the fractions. For number 12, same idea. We plug in 9x plus 24 into the y in the other equation, solve for x, and then take that x value and substitute it into one of the two equations to get our y, and that's our solution for number 12. Okay, so that is substitution. Again, if you need to review any of this, stop, rewind, you can see it again. Next, we are going to look at elimination. So once again, saving myself some writing, I copied and pasted some steps in here. So when we're solving by elimination, we are going to make sure that both equations are in the same form. Generally, we want that to be standard form. Most of the time, you're given those in standard form, but sometimes you might have to move them. Second step, we decide which variable you want to eliminate. I look at things like, is there a way that I can multiply one of the equations by something instead of both, or is there already a set of the x's or the y's where they're opposites, those types of things to help me, but you can just choose whichever one, it doesn't really matter. Then we're going to multiply one or both equations by a constant in order to create opposite coefficients for the x and or the y terms. We add vertically, we solve for one variable, and then it's basically like we saw up above. We substitute whatever we got for that one half of the solution into the equation to solve for the other variable. Alright, from there, let's look at number 9, which really is supposed to be number 13. If it bothers you, there you go, number 13. That would be number 14. So we're looking for which variable we want to try to eliminate. So things I would look at, we have our x's that didn't change colors on me, so I crossed it out, trying to highlight. So we have our x's here, and we have 2x and 1x. So it's pretty easy to get to the second equation to have the same coefficient but opposite signs. If we wanted to get rid of the y's, or eliminate them, it would be a little more challenging because 2 doesn't go into 3 evenly, or 3 doesn't go into 2 evenly. You have to multiply both equations. So I would look at going ahead and canceling out or eliminating the x's then. So then we're going to go ahead and multiply this equation by, since the top one has the 2 times 1 is 2, we're going to multiply by 2. We also need them to be opposites, so make that a negative 2. Okay, technically, we're looking at multiplying the same thing on both sides of the equation. That's the proper way. But a lot of us shorten that up, and we'll just go ahead and kind of use one big set of parentheses and distribute everything inside. Same idea, it's just maybe not technically the correct way, but it's easy. Alright, so we're going to distribute our negative 2. We have negative 2 times x, negative 2x. Negative 2 times, let me go ahead and show my distributing here. Negative 2 times 2y, then we'd have negative 4y. And negative 2 times 9, negative 18. From there, we're going to take that first equation that we had up here and go ahead and bring it down with this one. So we have 2x minus 3y equals negative 2. Alright, so we got through those first couple of steps. Now we're going to add vertically. So I go ahead and just actually show that. So we have negative 2x plus 2x. Negative 2 plus 2, 0. They're canceling each other out. Negative 4y plus negative 3y. Same time we're adding those together to get 7y. They're both negatives, so it stays in negative 7y. Equals negative 18 plus negative 10, negative 28. Go ahead and divide. And we end up with y equals 4. So as I did up above, I like to go ahead and show the ordered pair as I know things. I know the y value is 4. I need to find the x. And again, at this point, it doesn't matter which equation you pick. I again like to use the first one. So I have 2x minus 3 times whatever y equals negative 10. And then again, what did we solve the first time to get for y? We got a 4. So we plug in that 4 for the y in the equation we chose. And then we simplify. So we're going to simplify this. So 2x minus 3 times 4. 3 times 4 is 12. So 2x minus 12 equals negative 10. Solve your two-step equation there. Add 12 to both sides. 2x equals 2. Divide by 2. So x equals 1. And there is our solution. As I mentioned above, take the time, plug it in, make sure it works in both equations. It does. I'll try to clean this up, make it look a little bit nicer there. So we have the solution of 1, 4. Alright, next one. We have 5x plus 7y equals 41 and 10x plus y equals 43. So again, we need to decide which variable we want to eliminate. And realistically this time, it's kind of your choice because they're both relatively easy to work with. We can multiply 5 times 2 to make it a 10 like the second equation has, or if we're looking at this one, we have a 7 and a 1, so we can multiply the second equation by a 7 negative so that they cancel. I prefer to multiply by a smaller number, so I am going to go ahead and choose this first equation. And again, I need the x's in this case, because that's where I decided to work with. I need the x's to have the same coefficient but opposite sign so that they will cancel. So I have a 10 below, 5 times what is 10? 2. But I need a negative so that it will cancel, and then go ahead and distribute that to everything inside of parentheses, or both sides of the equation. Alright, so we have negative 2 times 5x, negative 10x, negative 2 times 7y, negative 14y, equals negative 2 times 41, negative 82. And then we're at the step where we add vertical. So our x's, 10x minus 10x, or plus negative 10x. Those are going to cancel. We have 1y minus 14y. That would be negative 13y equals 43 minus 82. So we're subtracting a bigger number from something smaller. I know I'm going to get a negative. And we have negative 39. You can always check with the calculator if you need to, or don't believe it. Alright, we're going to go ahead and divide to finish getting y by itself. So y equals negative divided by negative is positive, 39 divided by 13, 3. So I know half of my solution right now. I just have to plug that in to solve for the other half. So at this point, pick an equation. Again, I like to use the first one, but it does not matter. 5x plus 7 times whatever y equals 41. Alright, so what was y from our previous part of this? 3. We substitute that 3 for the y. And then we go ahead and start simplifying and solving for the x. So I have 5x plus 7 times 3 is 21 equals 41. And now we're down to a two-step. Subtract 21 from both sides. 5x equals 41 minus 21 is 20. Divide by 5. So x equals 4. So there is our solution to that system of equations for 3. Again, plug it in, check your work, make sure it works in both equations. It does. And at this point, you have 2 problems left there at the bottom. Go ahead and pause the video, try those on your own, and let's see how you do. Okay, hopefully you tried those on your own. Let's look at these bottom 2. Alright. So for the first one here, number 15, Again, you need to decide which one to eliminate. If you chose the y's, you'd have to multiply both equations by something. So I chose the x multiplied by -6. So distribute my -6, end up with this new equation, add them together, solve for y. Please ignore that. Good thing we're almost done. And once you have your y, go ahead and substitute that into one of your two equations and solve for x. And then for 16, same idea. The work is here. Please remember, if you are stuck and have questions, contact your teacher. Thank you very much.